Hello and welcome back to my channel. So we're going to be talking about some more related 1 over cosine squared theta d theta over dt equals 1 over 200 dA over dt. So we're going to go ahead and plug stuff in. So I have 1 over cosine squared of, our theta is tangent inverse of 3 times d theta over dt, which is what we are solving for, equals dA over dt is 100, so I'm going to put 100 over 200. Well, 100 over 200 is the same thing as 1/2 d theta over dt. And then we are going to go ahead and multiply by the cosine, or the cosine squared of the tangent inverse of 3. So d theta over dt is equal to cosine inverse squared of tangent inverse of 3 divided by 2. If we plug this into a calculator, we are going to get that cosine squared, everything in the top is going to be 0.1, so 1/10, and if I divide that by 2, that's going to give me 1/20, or 0.5. When I did this problem in the calculator, I got the same answer for both radians and degrees, but generally speaking, we like to look at radians a little bit more. So for this answer, I'm going to say the rate of change of the angle of elevation of the observer's line of sight is increasing at a rate of 0.5 radians per minute when the balloon is 600 meters high. So it's a little bit of a mouthful, but it is specific. The rate of change of the angle of elevation of the observer's line of sight is increasing at a rate of 0.5 radians per minute when the balloon is 600 meters high. Okay, we have one more here. So, a baseball is hit along the third base line with a speed of 100 feet per second. What is the rate? At what rate is the ball's distance from first base changing when it crosses third base? So we're going to be looking at this as a right triangle. So when it crosses third base, it's going to be crossing over here. So our triangle is going to look something like this, where this is a right angle, even though it doesn't look like it right now. So what we know is that the distance between home base and first is 90 feet. The distance between home base and third is 90 feet. So we know this much right now. We are also going to be looking at this triangle, and we want to talk about the distance, the rate this distance is changing. So one of the things that we know about this is that because both of these sides are 90 degrees, this makes a 45, 45, 90 triangle. 45, 45, 90 triangles have a special relationship. It is the short side, or the side that's the same as the other one, times the square root of 2. So if I want to know the distance between this side of x, I'm going to take 90 and multiply by the square root of 2. If I wanted to, I could just use Pythagorean theorem to solve for it instead, having a, b, and c. But if I know that relationship, I don't need to. If we use the Pythagorean theorem, you get 90 squared plus 90 squared, which is, after it's added together, 16,200, the square root of 16,200 is the same as 90 times the square root of 2. So for this problem, we're looking at distances, so we are going to use the Pythagorean theorem. So we have our Pythagorean theorem, a squared plus b squared equals c squared. We're going to use x instead of c because that's what they use in the problem. We could use s, but I don't really like it. So I have a squared plus b squared equals x squared. So if we take the derivative, we get 2a dA over dt, 2b dB over dt, and 2x dx over dt. And just like any other time we use the Pythagorean theorem, we can go ahead and divide everything by 2. So a dA over dt, b dB over dt, x dx over dt. We're going to plug in everything that we know. So I know a is 90. The rate that a is changing is at 100 feet per second. B is also 90. The distance between home and first is never going to change, so we're going to plug in 0. X we know is 90 times the square root of 2 times dx over dt, which is what we're solving for. We have 90 times 100, so we have 9,000. 90 times 0, which is 0. So 9,000 is equal to 90 times the square root of 2 times dx over dt. We're going to divide both sides by 90 and the square root of 2, but if I divide both sides by 90 first, I get 100 is equal to the square root of 2 dx over dt, and dx over dt is 100 divided by the square root of 2. If we plug this into our calculator, we're going to get 70.711 is about what dx over dt is. So what this tells me is the rate when the ball crosses third base, the rate the ball's distance from first base is increasing at a rate of 70.711 feet per second. So when the ball crosses third base, the rate the ball's distance from first base is increasing at a rate of 70.711 feet per second. So with related rates, we just kind of keep in mind that every problem is a little bit different. Everything is just kind of relative to what we're looking at, and we just need to be able to identify what we're looking at to kind of help us decide what to do.